All right, guys, here we are. I'm going to vodcast the solutions to 3.5p. I do apologize. Tablet is not around right now, so I'm going to use the document camera. So here we are. We're doing homework 3.5p. I tried to make it a little bit bigger for you guys this time, but this is the best we got right now. So this was from the 2000 examination, and let's go through the questions here. The first question says, actually it's just one question, it's D. It says, selenium reacts with fluorine to form SeF4. And it says, draw the complete Lewis electron dot structure. Same thing as just saying the Lewis structure. For SeF4, and sketch the molecular structure. So this is basically the picture from 64, 65, or 66 that we see. Not really sure exactly what that looks like, but it's good practice for us to get used to doing it. So it says, indicate whether the molecule is polar or nonpolar and justify your answer. Okay, so first, let's make some predictions about what polar means. Polar means there's going to be pairs, and the real meaning is it's asymmetric. Nonpolar means there's no pairs, and that means that it's symmetric. Now, when I say pairs and no pairs, what I'm really referring to is on the central atom. Okay. So we're looking for pairs, we're looking for no pairs on the central atom. Obviously, what I'm going to have to do first is draw the Lewis dot diagram for SeF4, and I'm going to do that here first. What I'm going to do right here is I'm going to do my skeleton structure first. So I got Se, I got F, I got F, I got F, and I got F. So I got my 4 Fs. And I look up on the periodic table of elements, and Se is in the same family, it's in the oxygen family. So Se is going to have 1, 2, 3, 4, 5, 6 dots. And we know that all of the halogens have 1 left over. But since I'm on a free response problem, I'm going to go ahead and show all the other dots, even though they are non-bonding electrons. Okay? So here we go. We're going to connect the lonely dots. Boom. And I've hit a dead end. So what I'm going to do is I'm going to take these up and I'm going to split them up. And that's what it's going to look like right there. Okay? So they want you to draw it according to what we see on the chart. Okay? I forget what page it's on, but I'm going to go over here and grab a book. And I'm going to look on page either 63, 64, or 65. And what I got here is I got 4 lines and 1 lone pair. So I'm going to look around for 4 lines, 1 lone pair, and I see that 1, 2, 3, 4. It's on the bottom of page 65, and that's going to be called a distorted tetrahedron or a seesaw. So the way they have that drawn, I'm going to draw it according to the way they do it. They have Se in the middle, okay, and they have 1 going up to 1 fluorine, 1 going down to the other fluorine, 1 going down to the other fluorine. Then they're going to have 1 of the fluorines wedged coming out of the board like that, and then they show the lone pair right there. And we have all the leftovers. Going on. Okay, so there's the molecular shape that they asked us to sketch. Okay, and they want to know if it's polar or nonpolar. So here we go. Boom. Okay, lone pairs on central atom create a asymmetric shape. thus it is polar. There you go. Okay, so let's go through this one more time, guys. We looked at it. They gave us SEF4. Okay, they asked us to draw the Lewis structure, and they asked us to sketch the molecular shape. Then they asked us to indicate whether it was polar or nonpolar. So we made some predictions first, and those predictions can be seen right here. We said that if there are pairs, it's asymmetric, and we said if there are no pairs, it's symmetric. Pairs refer to the central atom. We know that pairs would mean that it's polar, no pairs would mean that it's nonpolar. So we did the Lewis structure out right here. We drew it according to the shape right here. That's on the bottom of page 65. And we noticed that on the central atom there are lone pairs of electrons. This creates an asymmetric shape, thus it is polar. All right, guys, take care.